Hello everyone, the green car's back and I need to do some maintenance or diagnosis on it because it's been getting harder and harder to start. Every time it's warm especially, it just doesn't want to fire. I know it's getting fuel, but the ignition system is just not firing. Once it's running, it runs great. Today I had to swap the distributor just to get it over here. So I'm going to diagnose what's happening, and I thought you guys might like to see the troubleshooting. Feedback I get on the channel is that I only show, the good stuff and how nice everything's running and all that. It's not all roses here. Things definitely go wrong. I know electrics is not everyone's favorite. Let me give you a little background on the car. So this engine is a 912 engine. This is a placeholder engine. I'm gonna be redoing the original numbers matching engine probably next year. But this is basically the same engine. It is 6 volt for a Porsche 356 SC. Everything here is pretty much stock except for it's a 1720, so larger pistons and cylinders. I was running the 123 distributor, and I'm not saying that's the problem yet, but to get me here, I put in this replacement distributor. This is the Bosch 050. So I always keep a spare distributor in the car, and it's right here in this footwell area. So a couple spare parts in there. That's where I keep an extra distributor. This is the 123. The instructions say this works with 6 volt systems, anywhere between 14 and 4 volts. And it's been running fine. It's a fully programmable electronic ignition. And it's a great product, but I'm not so sure it's robust enough for 6 volts. My suspicion with this is that while you're cranking, it's 6 volt car, while you're cranking, the voltage at the coil probably drops below 4 or close to 4, and it's just marginal. So if the 123 is not getting enough juice, it can't function. And that's kind of what I'm feeling, is that there's no ignition at all. So even though the car is starting fine with the 050, I'm still going to troubleshoot it as if it wasn't, because in theory the 123 should work. So I'm going to be looking at all the wiring, the electrical switches, like ignition switch, the fuse block. Just want to figure out where this electricity is going and why it's not enough to power the 123, because theoretically it should. It's designed for 6 volt cars, but like I said, 6 volt cars, everything has to be absolutely perfect, including the coil, the fuses, the wiring, the starter, the distributor. Everything has to be like perfect. The carburetors have to start right up. I'm not gonna put the 123 in just for troubleshooting. I'm gonna look at the voltage at the coil with the 050 in. It really should be the same. The only thing the 123 does different is it does pull a little extra power to run its internal circuit. It's got a circuit board inside the 123. And that's what does all the programmable ignition and Bluetooth and all that stuff. So it's possible that that's enough current to just drop it in voltage to where it's below the threshold. Okay, battery voltage might be a little low because I haven't really been driving this car that much because it's been acting weird. But let's see what we get. 6.45. And everything is tight on the battery. So I'm going to set up this voltmeter back here, and this is the wrong color, but this goes to engine ground. I'm just going to connect that right here to the base of the distributor. And then this side will go to the positive side of the coil, which is this one. So with the key on, we should see that jump up to around 6 volts. So I'm getting 6.01 there, and depending if the points are open or closed, it could be pulling some current, which is why it's less than the battery voltage. So this is a separate meter I'm going to use. This will measure current, just a current clamp. So I'm going to clamp it onto that wire when the key is on and see if it's powering the coil or not. So I don't know if you guys can see that, but this is reading 6 volts and this is reading 4.5 amps. That's okay to know that. The 4.5 amps are going into the coil. You shouldn't leave the key on when the points are closed. So I'm going to move the engine so that I can open the points. Just put the car in gear. And right there, now the points are open. It went back up to the battery voltage, which is 6.34. And the current going into the coil is now 0. I'm going to remove this center wire because I don't want to start the engine. I just want to watch this voltage and see what it does while the engine cranks. And this is where the camera is handy since I really can't watch this while I'm cranking. Got to make sure it's out of gear. All right, so I'm seeing what you're seeing. I looked at the video. I saw about 5 volts while it was cranking, and that means I lost about 1.3 volts somewhere. Now, no battery is perfect. It's gonna drive the starter motor, and that's pulling hundreds of amps with a 6-volt system. So you would expect that with that much current going to the starter that the battery's gonna dip in voltage. That's actually normal. There's no perfect battery. So the question now becomes, is there anything that I can do differently to that wire that runs between the battery and the coil? So there's a bunch of things in between there, including the ignition switch. So I'm going to run another test and see how much voltage drop is there between the battery and the coil while it's actually cranking. I got this wire that's pretty much the length of the car. And it's a heavy gauge wire. It's probably, I don't know if I could read this. It's a pretty thick wire. It's certainly not going to have any voltage drop on it because the meter doesn't suck much current. It basically is going to just allow me to reach the battery from behind the car. So the end of this lead is connected to the battery, right to the 6-volt side of the battery. So we cannot let this touch ground, but I can clip it on here and just set it down on the floor. So this is somewhat protected by that alligator clip. So that's going to go down low so it doesn't make contact to anything metal. And then the other lead of the meter is going to go right here to the plus side of the coil. Okay, so now the ignition switch is turned on and I'm getting 17 millivolts, so 0.017 volts. That's pretty much 0. There is, like I said, potentially a little bit of drop depending on whether there's current flowing in the coil. So let's get that meter again and see if there's any current flowing. Okay, so I'm going to check and see if there's any current flowing in the coil, and right now there is not. Yeah, the meter is pretty much reading, 5 millivolts, and then when I connect it here, I'm getting 17. It's essentially 0. So out of the percentage of 6 volts is very, very small. So now I'm going to crank the car, and we're going to watch this number and see what the voltage drop is while it's cranking. The fuel is shut off, by the way. I saw 0.2 volts as the engine was trying to fire. That is, 0.2 out of 6.3 is not ideal. So most of that drop that we saw earlier, the 1.3, that voltage drop is largely due to the starter. And there's nothing we can do about that. It needs all the power it can get. But while the starter is using power, we're getting, out of that 1.3, we're getting 0.2 voltage drop to the coil. So if the circuit for the coil was perfect, we would only be dropping to, I guess, 1.1. And the voltage drop going to the coil was kind of bouncing around, whether the coil was charging or discharging. So now the question is 0.2 acceptable? It probably is, but I'm gonna dive a little deeper and see where the 0.2 is from. I'm gonna go from the battery to the fuse block or to the ignition switch. So Greg Bryan makes these great maps, which is basically we're gonna go all the way from the battery, which is, here. And we're gonna go all the way from the battery to the coil and measure things in between. So here's the battery, the engine coil is here, and so there is a black-white wire that goes to the ignition switch. The wire from the battery is 10, so that's its size in, I think, square millimeters. And then the wire that goes here is a 6 square millimeters to the light switch. And then I think it's the same, no, it's a 4 wire to the ignition switch. And then it goes down to a 2.5 till it gets to the coil. So, power gets pulled in different directions from each of these functions, whether it's the lights or the radio or anything that's driven by the ignition switch. But let's put our probe between the top of fuse 3 and the battery and see if there's something potentially wrong with maybe just this wire here. And then we'll move on down the map and see, what's the real driver for this voltage drop, because I wouldn't think that a 10 square millimeter wire would drop any volts when there's not that much current being asked of it. We don't have the headlights on. All we're trying to do is fire the ignition coil. Nothing else is on. Okay, I'm connected to the top of fuse 3. I know there's a bunch of fuses missing because this car is not fully assembled yet. But I'm at the top of fuse 3 and the battery terminal positive. So let's crank it and see if we have any voltage drop here. So that one came in at almost 1/10 of a volt. I got 0.09, kind of fluctuates again. But that's a little more than I would expect from such a heavy gauge wire. So I'm going to clean the battery terminal. There's a wire that gets clamped onto not the post, but to the battery clamp. I'm gonna make sure that connection's good, and then I'm gonna clean the connection on the top of the fuse block. Okay, I've just cleaned up the battery terminals, and that 10 millimeter cross-section wire, I moved it from the terminal clamp where the wire gets kind of scrunched down, and I moved it to the actual post bolt. I think that's a better position for it. I'm able to get a little bit more torque on it. That terminal has already been replaced. It's actually a gold-plated end. It's a nice piece. I replaced that when I renovated the harness. It's not a brand new harness. But let's try that test again. I also tightened up the screws and cleaned the contacts on the fuse block. So just to repeat, this is from the battery terminal plus to the top of fuse number 3. Okay, that was awesome. 0.015 is what I saw in the camera. That is essentially 0. It's really good. That's a heavy gauge wire. The connections are now perfect on that. So now I'm going from the top of fuse 3 all the way back to the coil. So this is gonna measure the voltage drop across the wiring from front to rear and also the switches. So there's a headlight switch. I think it's just a shared contact there, but there are some bullet terminals on the headlight switch. And then the ignition switch. So that's kind of 3 things we're testing all at once, but I don't really want to probe under the rest of the dash if I don't have to. These numbers are pretty small. So I'm getting from the top of the fuse to the actual coil, I'm getting like 0.15, which is essentially the same as to the battery, 0.16. That's a pretty small number for voltage drop, considering the ignition switch has moving contacts and all that. I've had the ignition switch apart before. I've replaced the entire wire that goes to the coil. So I was kind of looking for a bigger smoking gun, like a 1.5 volts or something like that. So the car itself, the battery, the ignition switch is all in good order. There's no reason why the 1, 2, 3 should not fire up unless it itself is pulling too much current and drawing the voltage down. I've replaced the coil. The coils rarely fail. I don't think the coil's the issue. So I'm gonna go ahead and put that coil wire back on and fire it up a couple times, do some driving with it, and just see if I can reproduce the problem. Like I said, the starter probably pulls a little bit more current when it's hot. They're just less efficient when they're hot like that. Just turn the fuel back on. That's how it should be. It seems like it's a little bit behind on timing, but much better. So pulling the distributor on these cars is really not that hard. Just want to disconnect it from the negative side of the coil. That's also where the tachometer connects. Pull this cap. And then we want to verify that it's pointing to number 1. So number 1, my wires are labeled, but number 1 is right here. And there's also a notch in the distributor for number 1. So when this cap was on there, this is number 1. So all I have to do is turn the rotor or turn the engine so the rotor is pointing to that notch, and then we can just lift it out. I don't want to knock the camera over, so I'm just going to use the wrench to turn the engine now. So that's it. This is pointing to the notch on number 1, and the lineup on the pulley is pointing to the notch in the crankcase. So this is firing top dead center number 1. This is the same procedure you would use to adjust the valves and stuff. It's just a typical starting point. So now I'm just going to remove this M8 nut here. That's it. So this clamp is still tight, but you don't need to unclamp it. You can just lift it out, which is also handy if I put this back in as a spare. I'm just going to leave this clamp on there if I have another one. And that way there, if I have a problem on the road and I don't feel like playing with points, I'll just drop this one in and remove the other one because I know this one works and I know it's already preset. The only other word of caution is you don't want to drop anything in here. It doesn't go down that far, but make sure you protect that. And then also do not turn the engine, especially backwards. I think forward's okay, but if you turn the engine backwards, it can mess up the teeth on that drive. Okay, so here's the original distributor, 022. Comes in the 912 and the 356C and the SC. It's quite a bit different than the 050, and this just has more advanced quicker. So hopefully this will work okay. So same thing, when we install it, we just want to line up cylinder number 1 right there. And this slot is offset, so that should drop right in. You just want to confirm that the thin side is towards me. So the thin side is towards me, lined up with number 1. This clamp is loose, so we'll have to adjust the timing, but basically just drop it in the hole. Give it a wiggle. Make sure this is engaged into the slot. There it is. So that is locked in all the way down, and this will no longer turn. It's now being controlled by the crankshaft. This is the timing adjustment. So we just basically line it up roughly right there. That's number 1. And we'll put the nut in, lock it down. 6mm nut will also get locked down. That's what locks the timing adjustment down. Now this one doesn't need to be super tight. I just do finger pressure and then check it so that it's kind of locked. It's not going to turn on its own, so just make sure it's locked in. If you overdo it, you can bend the clamp, so that's plenty. And now we just need to change the cap because the 050 uses a little different cap. So we just want to pay attention to where the wires are. It's 1 where the notch is. 1, 4, 3, 2. That's the firing order, and it rotates this way. So we'll just change one wire at a time. This has a tab right here, so that only fits one way. 3. 2. 1, 4, 3, 2, that's it. And then the center wire. Goes right there. And then we need to connect on the back of here, there's a wire that goes from the points to the distributor. That's what tells it to turn on. That distributor's in, and I am going to wrap this one up and put it right back in the spare parts little hideaway. I carry all kinds of stuff like pulleys and fuel pumps. I carry a coil. Let's see if it starts with this one. So it's just too far retarded. So I'm gonna loosen that up, advance it just a little bit, and then we'll try again. I'm gonna get the timing light and do it correctly, but move that just a little bit. In fact, I'm gonna leave it slightly loose so I can adjust it with the timing light. Let's try again. It's a real low idle. But the engine's cold, so there we go. Let's just let it warm up a bit, and then we'll check the timing light. Then we'll check the timing with the light. The timing is not super sensitive to temperature, but it really should be on a warmed up engine. So I've got it adjusted, it's running better. I do like 5 degrees before top dead center, and then a total of like 34 degrees max advance. So I have marks on my pulley. They're painted on because my timing light doesn't have an advance function. It just fires whenever the spark plug fires. So I just have to mark new areas on the pulley so I know where 30 degrees is, I know where 35 degrees is, and I target it, you know, 3/4 between those two marks at like 3,000, 3,500 RPM. And then at idle, it ends up being whatever it is, but it's about 5. So total advance is about 29, something like that, 28, 30. And it's running great, idling great. It's returning back to idle just fine. So I'm gonna go for a ride in the dark, which is great because I want to check the starting with the headlights on and just kind of put it under some heavy stress to make sure that I'm not going to get stuck again. And then if you're wondering how I connect my timing light, I just connect it to a 12-volt battery And then the 12 volt battery, which I have on my winch here for my garage, is connected to the car with a common ground. So as long as you have a common ground and the timing light's running on 12 volts and you have it attached with the ignition lead, it doesn't hurt anything. It doesn't hurt the car, it doesn't hurt the battery, it can run like that forever. So I've been driving the car quite a bit. Last night, like 45 minutes, stopped multiple times, get gas, grab some dinner, pulled over, started it, stopped it, pulled it in the garage, started it, stopped it. Today I've been driving it, cold start, warm start, no problems with its current setup. So I'm a little bit suspect of the 123 distributor. I don't know if it's just marginal or something might be wrong with it, but it's running so well with the 022. I'm just gonna leave that in and deal with the points. You know, you change the points every 2,000 miles or less. You know, they wear out pretty quickly, or they need to be maintained often. But to me, that's the lesser of the two evils. You just maintain the points and have reliability with the 6-volt system. So hopefully that helps. I know this was super detailed and lots of information about voltage checks, which ended up being somewhat helpful. I mean, I made a small improvement, but I think the problem really lied with the distributor.